All right, so this next section that we're going to be looking at, we're going to jump over 2.3 and we're going to look at 2.4. This is looking at forces in space. And all that that means to us is that now we're not just going to be working on the X and Y axis, or on, like, if you would, just a flat piece of paper, 2D, 2 dimensions, X and Y. We're going to add the third dimension, Z. And in this section, what we're going to first do is we are going to figure out how to break forces in their X, Y, and Z components. We already know how to do X's and Y's, but now this Z axis adds a little bit to it. And then what we're going to do is we're going to learn how to determine resultants of multiple forces that are in the X, Y, and Z planes. Okay, so as we look here, you're going to notice that we have force X, or force F. Force F, you can see based on kind of that glass looking plane that's around it, plane O, B, A, and C, that it is tipped forward, if you would, or rotated forward off of the Y axis there, if you think of that as a hinge. And so now what's happened is it has like a component or another force that is going to affect how it's actually going to, if you would, perform in space. It's not just in the X and Y axis anymore. Now, when we want to show this in 3D space, I'm going to go a little bit further here. We want to actually find out what are the components on each one, bless you, each one of the axes here now, including the Z. So every one of our forces in this section are going to have an X component, a Y component, and a Z component, okay? So as we look here, you're going to notice that when we look at the angle coming off the x-axis, this is called angle phi. So it's just a designation for an angle. And if we wanted to determine what the x component would be here, we would take the cosine of that angle from the hypotenuse or that force, okay? Now, as we look forward, it says here expressing vectors in 3D space. This is where I just want to caution. In this book, they use the designations I, J, and K to say that this is a vector quantity. So they'll say Fxi, Fyj, and Fzk, meaning that that is the designation, that letter I, J, and K are going to be a vector. As you know, when I write vectors, I just put the little arrowhead above each one and I leave off the I, J, and K. We have plenty of variables to worry about. So I will not be including I, J, and K whenever we're adding things, just so that you know. I'm going to keep it to X, Y, and Z, and we're going to know that they're going to be vectors along there because that's how we're going to be drawing it and such. Okay. Now, as we look here, it's just another, I like this view because it's a nice cube. So if you would, our force is coming up here. This is the red force. And then you're going to notice that it has a Y component, an X component, and a Z component. Those are going to be the ones that we're going to be interested in finding, because what that allows for us to do, just like we did for the X and Y axes, we can then add and subtract along those axes based on their positive and negative values, based on the directions that they're in. And then they're easier to algebraically add together rather than trying to use the trig. Now, equations that we're going to use, okay? Equations that we're going to use. What I want to do, I'm going to kind of go ahead here. We are going to be looking at sample problem 2.7. But before we do, it's worth kind of generating a little list here of the equations that are going to come in handy. So I'm going to go underneath here, okay? And the equations that are going to come in handy are going to be as follows. Okay, when we have a force F, okay, and I'm going to just write equations. Okay. When we have a force F and we want to find the Y component, our Fy is going to be equal to F times the cosine of theta, okay? We also know that our Y component, or I'm sorry, our X component is going, wait, I did that wrong. Sorry. Fx is going to be equal to f times the cosine of theta. And we know that the y is the f times the sine of theta. Okay. The fz is then going to be f times the cosine of theta z. Okay, and that'll make a little bit more sense in a little bit. Okay. Now, when we want to find the resultant after we've gotten each one of our components, our resultant f is going to be equal to the square root of fx squared plus fy squared plus fz squared. Okay. We're also going to find that there are going to be distances that we're going to get that are offset from the origin. So when we have distances, our overall distance or the length of our resultant distance vector is going to be equal to dx squared plus dy squared plus dz squared. Okay. All right, so that's a good starting point, and we are going to then use that. We're going to look at sample problem 2.7, sample problem 2.7, which is found. Wait, I'm sorry, we just did 2.7. We want concept problem 2.4. Okay, concept application 2.4. So concept application 2.4 says we have a force of 50 newtons, forms an angle of 60 degrees, 45 degrees, and 120 degrees respectively from the x, y, and z axis. So this is going to be 60 from the x, 45 from the y, and 120 from the z. They want us to find the x, y, and the z components, the x, y, and the z components. Now, so what we're going to do is we're going to follow along. We're going to say, okay, for this force, so this is concept application 2.4. And our F is going to be 500 newtons. We've got theta X is equal to 60 degrees, theta Y, 45 degrees, and theta Z is 120 degrees. So to find each one of those components, Fx is going to be equal to F times the cosine of theta X. Okay, so this is going to be the angle off of the x-axis to that resultant that's in space. So we know that F is 500 newtons, and we know that angle theta X is 60 degrees. So our Fx component, I believe, should be half of that, which is 250 newtons. And yes, it is. Okay. And the next one we're going to do is we'll do the y component. Now, because they're giving us the y or the theta off of the y, we're actually going to use the cosine of the 45 degrees because it's going to be the side adjacent to the y axis. I don't think if they have a diagram where they show that. Yeah. So this illustration here on page 52, we have theta y. This angle, if we look with the hypotenuse, is the side adjacent. So it will be the cosine of theta y. Okay, cosine of theta y. So Fy is going to be equal to F times cosine of theta y. Theta y was the 45 degrees. So that means it's going to be 500 newtons, same force, cosine of 45. So Fy should be 353.6 newtons. Okay. And then Fc is going to be the same thing, the cosine of the theta z. So Fz is going to be equal to F times cosine theta z. So 500 newtons times the cosine of 120 degrees. So you get a negative 250 newtons. So what does that mean to me? It's going in a negative z direction. Okay. All right. So any questions on that? It's pretty straightforward. This section is just kind of giving us an introduction first to the components. Now let's work in the opposite direction. Let's look at concept application 2.5. Okay, concept application 2.5. Here we have a force F has the components of, they're giving us the individual Fx, Fy, and Fz. Okay, the negative in the Fy means that it's going in a negative direction, it's pointing down. They want us to determine the magnitude of the overall force, okay, and what angles theta x, theta y, and theta z would be. All right, so kind of working that same problem we just did, but in a backwards direction. They're giving us now the components, and we want to work backwards and figure out the resultant, okay? So this is going to be concept application 2.5. Okay. And here we are given Fx equal to 20 pounds, Fy equals to negative 30 pounds. Again, that's our direction, going down instead of up. And then Fz is going to be 60 pounds. So first things first, we will use that equation to find the resultant, okay? So it's pretty simple. Can't really say it's Pythagorean's theorem because we have a third variable, but we can figure out our overall resultant. We'll just call that F. It's going to be equal to the square root of Fx squared plus Fy squared plus Fz squared. Okay. And now putting those values in place, we're going to have 20 pounds. Make sure you can use a symbol for pounds, just include it as your units. Negative 30 pounds squared plus 60 pounds squared. Now, I did put the negative in there, but as you know, when we square a negative, it becomes positive. So if you don't put it in, that's okay too. All right. Because it's not really going to change anything as far as our number. So our value for F should come out to be 70 pounds. Did you guys get that? Okay. Any questions so far? Because we've got to do the angles, yeah. Okay. So now to do the angles, we want to find out what is theta x, theta y, and theta z. So as we know, cosine of theta x is going to be equal to, side adjacent, which is going to be its Fx component, divided by the hypotenuse, which is the 70 pounds that we just calculated, okay? So that means that from above, our Fx was 20 pounds. We just calculated 70 pounds for our resultant. Those units cancel. And we're going to end up with a decimal of 28.95, okay? That's not the angle yet. We need to take the inverse cosine of 0.2895, and you should get theta x equal to 73.4 degrees. Make sure you can do that, that comes out. So 20 divided by 70, and then the inverse cosine. So that's theta x. Then we're going to do the same thing. Cosine theta y, because again, it's coming off of the y-axis, so it's the side adjacent. Did you get the same number?
0.2857.
0.2857, is that what you got? 20? Oh, I did too. I must have written that wrong. I was watching the football game when I was doing these the other night, my notes. I always do them the weekend before, and sometimes, you watch TV, right? While you're doing your homework. I guess I was too, and maybe I wrote down the wrong thing. Now we gotta wait another week till football again. I like football. I like football weekends. It's fun.
Think the Chiefs are gonna win?
I don't know. Yeah, Chiefs or the Bills.
No.
It's gonna be monumental, or not the Bills,
Eagles.
the Eagles. I'm sorry. Yes, the Eagles. I wanted the Bills to win, unfortunately.
Nobody wants to see Super Bowl.
Nobody, well, it's kind of monumental. It could be 3 in a row. But I think it's kind of fun to see somebody else, right? Yeah.
Yeah.
Yeah, they're really good though, god darn it. They're just really good. Okay, all right, off subject. So what we're gonna do is we're gonna take our FY, which is negative 30 pounds, divided by 70 pounds. So 30, I better do this time. 70 divide. Did you get a point? Negative 0.4286. And then do the inverse cosine. So your theta y, bless you, should be 115.4 degrees. And then our last one, cosine theta z, it's going to be equal to fz divided by f. So that's going to be 60 pounds divided by 70 pounds. It's going to be 0.8571. So our theta z, taking the inverse cosine, should be 31.00. So yeah, 31 degrees. Those are fun. Any questions on those? All right. So what I'm going to do is we're going to, this is a good time to take a break because I've been talking to you for almost an hour and a half. So let me stop the recording.